topic for lesson 10.4 is inscribed angles. You'll learn to find the measures of inscribed angles and find the measures of angles of inscribed polygons. How is a socket like an inscribed polygon? A socket is a tool that comes in varying diameters. It is used to tighten or unscrew nuts or bolts. The hole in the socket is a hexagon cast in a metal cylinder. In lesson 10.3, you learned that a polygon that has its vertices on a circle is called an inscribed polygon. Likewise, an inscribed angle is an angle that has its vertex on the circle and its sides contained in the chords of a circle. So the vertex here is B is on the circle, and that angle is made up of AB and BC, which are chords of the circle, and ADC is the arc intercepted by angle ABC. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc, or the measure of the intercepted arc is twice the measure of the inscribed angle. In circle F, if the measure of arc WX is 20, the measure of arc XY is 40, the measure of arc UZ is 108, and the measure of arc UW equals the measure of arc YZ. Find the measure of the numbered angles. Well, before we can get our angles, we need to finish filling in our arcs. So I'm going to let these two of the same be x. So 2x plus 20 plus 40 plus 108 all the way around the circle. There are 360 degrees. So 2x plus, combine my like terms, 60 plus 108 would be 168. Subtract 168 from both sides. And divide by 2. X should be 96. So now these are both 96. That's what we needed to get started. Angle 1 is inscribed in arc UW, which we just found was 96. So we need 1/2 of 96. So the measure of angle 1 would be 48. Angle 2 is inscribed in arc XY, so we need 1/2 of 40 is 20. Angle 3 is inscribed in arc UZ, so we need 1/2 of, they told us UZ was 108. So 1/2 of 108 would be 54. And we're in degrees. Can't help myself, I'm going to skip ahead here because I can see that angle 5 is also inscribed in UZ. So that's also going to equal the measure of angle 5. It's also 54. And we still need to find measure of angle 4. It's not an inscribed angle. It's the third angle of a triangle. We've already found angle 2 and angle 3. So if we just add 20 plus 54 is 74, plus measure of angle 4 equals 180. So all we have to do is subtract 74 from 180, and we have measure of angle 4. Oops. Equals 180 minus 74 should be 106, and of course we're in degrees. Better 6. In circle A, arc XY is 60 degrees, arc YZ is 80 degrees, and diagram not drawn to scale, measure of arc WX is supposed to equal the measure of arc WZ. Well, again, we know there are 360 degrees around the circle. So if I let my blue be X plus 60 plus 80 altogether should equal 360. So 2x plus 140. Subtract 140 from both sides, and we've got 220 divided by 2. Each of those angles should be 110. Measure of angle 1 is going to be half of arc xy. So 1/2 of 60 is 30. Angle 2 is inscribed in arc WZ. So 1/2 of 110 is going to be 55 degrees. Angle 3 is inscribed in ZY, which is 80. So it's going to be half of 80. Angle 4 is inscribed in arc WX, which is 110. So it's also going to be half of 110, which is also 55. Just like angle 2. And what do you know? The measure of angle 5 is also inscribed in WX. So just like angle 4, it's also going to be 55. The fact that angle 4 and angle 5 come out the same actually leads to our next theorem. If two inscribed angles of a circle, or incongruent circles, intercept congruent arcs or the same arc, then the angles are congruent. We just saw that. Points M and N are located on a circle so that the measure of arc MN is 72 degrees. Suppose point L is randomly located in the same circle so it does not coincide with M or N. What is the probability that the measure of angle MLN equals 144? Well, remember, probability is favorable outcomes over total. So the favorable outcomes is it's located in that arc. So that's 72 out of the total is 360. And then all we have to do is reduce that. 72 over 360 reduces to 1/5. If an inscribed angle intercepts a semicircle, then half of 180 would be 90. So it's going to end up being a right angle. And here's just a little reminder. Remember that for a polygon to be inscribed, all of its vertices must lie in the circle. Triangles TVU and TSU are inscribed in circle P with VU equal to SU. Find the measure of each numbered angle. If the measure of angle 2 is x plus 9, the measure of angle 4 is 2x plus 6. Well, first we probably should find x. So we can see that these are the three angles of a triangle, so we know they're going to add up to 180. So x plus 9 plus 2x plus 6 plus 90 for the right angle equals 180. So combining our like terms, we have 3x plus 15, subtract 90 from both sides is 90. So 3x equals subtract 15 from both sides and divide by 3. So x is going to be 25. So that gets us the measure of angle 2 and angle 4. So angle 2 is going to have to be 25 plus 9, which is 34. And angle 4 is going to be 2 times 25. So that's going to be 50 plus 6. So the measure of angle 4 has to be 56 degrees. Now, because angle 1 and angle 2 are inscribed in congruent arcs, if 2 is 34, angle 1 must also be 34. And since two angles of the triangle are congruent, that means the third angle would have to be also. So that now makes angle 3 and angle 4 have to be congruent. So measure of angle 3 would also have to be 56, and I think we've got them all. Quadrilateral QRST is inscribed in circle M. If the measure of angle Q is 87, the measure of angle R is 102, find the measures of angles S and T. Well, the measure of arc RST must be twice the measure of angle 2 because angle is inscribed in it. So 2 times 87 gives us 174. And we know there's 360 degrees all the way around the circle, so measure of arc RST, which we just found was 174, plus the measure of arc RQT must be 360. So all we have to do is subtract 174 from both sides. And we get measure of arc RQT to be 186. And so if RQT is 186, angle S is inscribed in that. So the measure of angle S is 1/2 of 186, which is 93 degrees. Now in the book's example, they repeated that process to find their fourth angle, but I think that's kind of silly because we know something about the angles of a quadrilateral. We know that they should add up, they do add up to 360 degrees. So I think this would be easier. I'm going to do it this way. So when we add up the three that we already know, we get 282. So if we subtract 282 from both sides, we get the measure of angle T to be 78 degrees. And if we look back there, there's something interesting that happens. Angle Q and angle S are opposite angles in that inscribed quadrilateral, and they add up to 180 degrees. And what do you know? Angle T and angle R are also inscribed or opposite angles of that inscribed quadrilateral, and they also add up to 180 degrees. So that gives us our next theorem. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. And the reason that's happening is because altogether we're inscribing the entire circle, so 360 divided by 2, there's our inscribed angle, is always going to be 180. The measures of the inscribed angle is half the measure of its intercepted arc, and angles of an inscribed polygon can be found by using arc measures.